Dispersion occurs when polychromatic light is separated into its component wavelengths. The most well-known example of dispersion is this picture of white light being dispersed by a prism, made very famous by the Pink Floyd album The Dark Side of the Moon. Dispersion occurs because different wavelengths of light interact differently with matter. It turns out that shorter wavelengths of light interact more with matter than longer wavelengths. The shorter wavelengths, namely the blues and the violets, are slowed down and therefore bent more than the longer red wavelengths. In other words, the index of refraction actually depends on the wavelength of light. The index of refraction, for example, of a red wavelength for a given material is actually a little bit lower than the index of refraction for a violet wavelength. By convention, the accepted index of refraction for a given material is for a wavelength of 589 nanometers, which is neither violet nor red, but somewhere in the middle. Because the index of refraction differs for different wavelengths of light, the various wavelengths traveling through a lens focus at slightly different points. The resulting blurring is called chromatic aberration. Let's give an example here. We have a converging lens, which of course has two focal points because this lens has two surfaces. If we have white light that is incident on this converging lens, let's break it into, let's say, three colors. The wavelengths that are bent the least would be the red wavelengths. The wavelengths that are bent the most would be the violet wavelengths, and the wavelength that would go right through that focal point would be the one that gives us the index of refraction of this glass, 589 nanometers. Chromatic aberration is reduced by combining converging and diverging lenses made from different materials. We cannot completely get rid of chromatic aberration, but we can minimize it in this way. Dispersion occurs when polychromatic light separates into its component wavelengths. Dispersion is the result of wavelengths interacting differently with the atoms of a given material. For the visible spectrum, red light interacts least with matter and is therefore refracted least. Violet light interacts the most and is refracted the most. The phenomenon of rainbows and the behavior of light through triangular prisms are two well-known examples of dispersion.